So I wanted to keep it pretty informal overall, but I did come up with a little agenda, and I wanted to start with the real basics of this program because I do know some people it'll be their first time using it, the first time looking at it, and other people probably have some solid modeling experience or some CAD experience, or maybe even with Fusion. But I wanted to start with the real basics, kind of as I figured stuff out and I've learned how to use it, thinking that might help other people that want to use it for creating 3D printed parts, or I do a lot of laser cut parts that I order, or machined parts, or Fusion can do a whole lot more. You can do like photorealistic renderings of scenes. You can create 2D drawings. You can do finite element analysis. You can use it to actually create like machine path tools for CNC machines. It's a pretty powerful program, and some of those features I've played with, and some I have not. So at some point, maybe in some future lessons, we can touch on some of that, or I can show you a little bit of what I have done and have figured out. But I wanted, just start with kind of the basic screen. So if you're looking at my screen share here, you've got Fusion. So this is a blank untitled document. This is what you see when you open it up. You might also see the data panel, which if you click on the little grid of squares in the upper left corner, you can either hide or show this data panel. And this is kind of like your folder, your directory for where all of your projects are. So it's going to organize everything as project. And so, you have project lists and project names. And if you click on a project, if you double click on a project, you can see all the parts that you have inside that project. And if you click on the little house, you can go back and click on another one. Let's see. So one that we're going to be looking at today is one that I created. This is what I sent the link to chat. So it's a little cannon. So it's here. So if you click on one of the items in your data panel here, if you double click it, it will open up on the other screen. And then if you want to hide that data panel, you can either click the little 9 little squares, or just the X on the data panel, and it'll close. So when you have something opened, there's a few things we have. We have the tools on the top. This is like a lot of Microsoft products or things like that. Our tool ribbon, and it defaults to the solid modeling version. And then you have all these tools. And then there's other ones like surface for working with surfaces of things. Meshes and surfaces are more like kind of free-form models that I have found. I do have an example of one or two. I've been playing a little bit with 3D scanning. So taking a 3D scan of a part. Typically you create a point cloud that turns into a mesh, and you look at it that way. There's a sheet metal section, which lets you design parts that are going to be native sheet metal parts. And then there's a plastic section. I haven't really used this at all, but I would imagine it's designing a part kind of native for injection molding. And then the utilities ribbon has a few other things here that I really have not delved into myself. So I don't know a lot of what these options are. But I typically either am doing stuff in the solid or the sheet metal version. But this is the ribbon. This is the tool ribbon at the top. This here in the upper right-hand corner is, I think it's called the view cube. And if you click and hold on this cube, you can rotate your model around. Like as you move the mouse up or down or left or right, your model will rotate in that orientation. And then you have a little house up at the top. And if you click that little house, it will recenter your model to the default orientation you have it set to. And if you wanted, you could move that model, and then you could, using the little drop down, you can actually reset your home position, or you could set the current view as home, right? So if I made this view home, then, now if I move it around and click the house, it'll go back to that view. Well, it didn't go back to that view. Why didn't it? Fixed distance. Good question. I don't know why that one didn't do. Well, in theory, you should be able to change your home view. If you click on one of the sides of the cube, like if I click on the top, it'll give me a top view. if I click on like, you know, the right side, it'll give me a right side view, or it'll give me the, you know, the front view. This can be useful when you're working with sketches on a 2D plane, and you know, you do some rotating to kind of see what's behind the part, and then you want to get back to looking at that same view. Another option with a little drop down arrow here is, well, first I'm going to go to home, is you have orthographic or perspective viewing. So orthographic is kind of like a real true dimensional cube where there's no perspective involved. So like this line here in the front would be the same distance on the screen as the line in the back. So if I turn it on perspective mode, you'll see it kind of shifted the model a little bit to make it look a little bit more like, you know, you're looking at it in real life with a little bit of perspective. And again, if I turn that off, if I go back to orthographic, you can see it just kind of changes the proportions, right? The rear of it gets a little fatter and wider in orthographic, where in perspective it looks, you know, a little bit more natural. Typically, I'll design stuff in orthographic mode because what it allows me to do, especially if I have a part set to transparent, like it'll line up right. You know, again, the back face of the cannon is now the same size as the front face of the cannon because there's no perspective distortion there. So this is the view cube, and you'll be using this a lot as you start working with solid models and looking at things and, you know, looking for, you know, is there clearance or space between parts, moving things around. To go with the view cube, you have some tools down here on the bottom, and this is the navigation bar. And the navigation bar, the main things that it has is the pan. The hand lets you, you know, slide your model or your view side to side. You have zooms. You can click zoom and you can, you know, go in or out. If you're using a mouse, you can also use the scroll wheel to zoom in and out, but you have that tool down here as well. This will just, you know, if you're zoomed way in and you click the fit, it'll just go back to, so you can see the whole object on the screen. And then next to it, you have these display settings. The display settings, the main one that I've used is under visual style. You can turn on like, you know, a wireframe, you know, so you're looking at just the edges of your object. You can look at just the shaded version of the object with, you know, so now like the lines, the edges are you know, not displayed, or where I had it just a moment ago, I had it shaded with visible edges, right? So now it's drawn black edges for all the sharp edges, which gives it just a little bit more definition. Depending on what you're drawing or what you're working with, you know, it might make sense to use one or the other. There's also, you know, with hidden edges, if you're trying to select an edge or something, or trying to see what is on the other side, that hidden edges, it'll draw the hidden edges in like a dashed line. So, you know, you can get a better sense for like the, you know, the little angle or slope that's on the inside of this block on the base. If any of these things disappear by accident, under the file menu, there is a view option, and these view options are for all of these things. The view cube, like if you know, I don't know, you do something and you're like, the view cube is gone. How do I rotate my model? You can go down here to the view and make sure that show view cube is listed, and then there it is up there. So that's one thing that you know, took me a little while to figure out. I did something and I somehow turned off this the navigation bar at the bottom. And I'm like, wait, where did this go? You know, and it took me a little while to find that. This on the side is called the browser, and this is where you have your tree structure. And like a lot of common tree structures, you've got little kind of triangle arrows that, you know, show if you've expanded the tree or the bulleted list. So this starts with, you have a name for your kind of your main component or your main item. In this case, it's the project, which I've named Naval Cannon. You have right under that, you have document settings. So every document has its settings. And this is where you can set units if you want to use your units as either millimeter or inch or foot or, you know, whatever. I'll typically use millimeter or inch. It depends on what I'm usually working on. If I'm trying to, let's say, make a bracket for, you know, a 944 engine that was originally designed in millimeters, and I know that all the hole spacings and all the, you know, the hole diameters and millimeters, I'm going to use millimeters for my workspace because I'll be taking measurements, and it's much easier to work in round numbers. But if I'm doing something else, I was just building something that I was using a lot of flat sheet metal, and the US, the sheet metal we get is all SAE, is all standard fractional sizes. So I decided to make my model in inches because I was using pipe, you know, that was 1.5 inches in diameter, and sheet metal that was 1/8, then 1/4, and 3/8. And it was easier to use those numbers than try to convert them into metric. So, you know, it's kind of whatever your personal preference is if you want to go with inch or millimeters, but you do that under the document settings section here. If you have threads, any threads in the model, you can choose thread types as well. Under that, we've got named views, and right now it just has these the views from the cube, top, front, right, and home. I think you can add more views, like if you're looking, you know, in a certain direction or a certain angle, if you added a view, it would show up there. Under that, we have the origin. This is kind of the 3 planes that start the creation of the model. When you start with a blank model and you're going to make a sketch for the first time, that origin pops up, and you can choose one of those 3 planes to start working on. Once you've started doing stuff, if you see the little eyeball here next to this arrow, this is an eyeball with a line through it. So that means that the origin is hidden right now. If I click it, it will then show the origin. So when I started this model, I was using this plane here. Under origin, we have construction. And so constructions are other geometries, other construction geometries you create, which are points, planes, or axes. And I'll explain why I created some of these in a little bit here, but they are under the construction tab. And if I expand this down, right, we can see the actual different things, right? So like this plane right here is plane number 1, and then there's a plane number 2, and all of these are in kind of the top level tree model. Because if you look next, the next thing we have is we have a component. So actually, let me turn off the eyeball for construction. So now I have components that these are the different actual models, the 3D models of the part. And this first one is the base of the cannon. And again, the eyeball is turned on, so you see it. If I click the eyeball, it hides it to turn it off. And then if I look at the tree structure here, it has a lot of these similar things as the main file does, or the top of the tree structure, right? So it has an origin. The base has its own origin. It has bodies. Bodies are the solid models. Sketches are the 2D sketches that create the solid model. So you can see this, there was 4 sketches that created this. And then it has the construction things as well. So you can have like your own construction items for a component as well. So this has a plane and an axis. I'm just going to hide those for a minute.
Van, I gather that the construction items are not part of the actual piece that's being designed. Is that correct?
So correct. Construction items are like reference items, reference things. So they have no physical geometry or size. You know, they don't have a thickness or anything like that.
Okay.
So if you were going to export this as a solid model for 3D printing or for manufacturing, the construction elements would not be part of that. They are more for reference and for the design. So if we get into a little bit, we'll jump right into a little. Well, we'll do that in a minute, Kevin, because there's another thing I want to show you after. Now that I've shown you the tree structure, I just wanted to say a little bit more. So I've got the components here. So now we're into the list of the components. Right? We've got the base, we've got the barrel, we've got the trunnion pin that holds the barrel, and then we've got a wheel and a screw and a wheel and a screw and so forth. All of these components, so the wheels and the screws are copies of each other. So I only needed to create one of each and then copy them. But if you're going to be working on one of these, there's a little circle with a dot next to it. And if I click this dot, like right now, this dot is selected for the parent, or the top level of the tree. So if I click on base and click the dot, it kind of hides the other components and shows me the base component. And so this is where I would do my modifying or my changing to this piece, to the base. And if I wanted to do it to the barrel, I could click on the barrel. And if I wanted to go back home, I could click up at the top and go back home. So we're going to come back to that as we step through kind of the steps that I took to create this. But the last thing I want to show you before we go into that is at the very bottom of the screen here is this timeline. This timeline captures everything that you've done to create your design. And if you go up to the top level, and if you right click, there is at the very bottom there's capture. So right now I have it capturing the design history. You can turn this off if you don't want it to capture the design history. Or if you start doing a model and you don't see these steps at the bottom, you might have to go and turn on the design history. But I find it a very important feature. There's a little slider, and I can now move this slider somewhere along the process, and I can see exactly what steps were done at that point. And there's some little controls over on the left side here, kind of like a VCR or play button controls, which actually allow me to play a little kind of animation of what it's going through to create the item. So this is drawing the base, and then I made the holes for the wheels, and now it's drawing the barrel, and then it makes the little pin, and now it makes a wheel, and I imported a screw, and then I placed the screw, and I make copies of the wheels and the screw, and I put them in their positions, and then the little model's done. So I can go through there, and I can see kind of the whole history of the part, and I can I could bring it here, and I could step through a piece step by step. And so, oops, I wanted to use the other button here. This one, the step forward, right? So the step forward. And so what I was going to do is kind of go through the items in the tree structure and go through the steps that I took to create it, so that everyone could follow along. And again, since you'll have this model you can reference, you'll kind of be able to see how I created it, and you'll be able to make modifications if you want, or changes. One of the beauties of the 3D modeling, the parametric modeling, is everything. The computer keeps track of all the relationships and all the measurements and everything. So if you made changes, like here's this wheel. If I wanted to, so this is wheel 1. If I wanted to go into edit wheel 1, go to my sketch. So right now I have this wheel as 22 millimeters in diameter. If I make it 32 millimeters in diameter, so it's bigger, go to finish, it has not only updated that wheel, it has updated all 4 wheels on the on the model to that, because the wheels are clones. The other 3 wheels are a clone of the first wheel. When you update that first wheel, it'll update all of them. So that's that's kind of the beauty of this 3D modeling, this parametric modeling, is to be able to make changes like that and update everything. And again, if you have other referenced geometries like so let me go back and put that wheel back where it was. Another example is, so that was 22. So like this pin here, this trunnion pin. In fact, I'll show you another little feature in the tree. So like this pin, this trunnion pin, if I wanted to focus on that pin, I could select it by selecting the little dot. So I'm primarily working with this pin. But if I wanted to remove all the other stuff around it, if I right click, there's an option for isolate. If I click isolate, it just hides everything else. So if you look, it just has turned off the eyeball for all the other objects. So I have just this object. So if I wanted to inspect it, this is like a measuring tool. I can click on the circle at the end, and so it tells me that I'm looking for the diameter here. Actually, because it's a surface, let me inspect just the edge of that part. Right, so the diameter is 7 millimeters on that pin. So if I go back, so I'm going to unisolate it, so it shows everything else. I'm going to go to my base part, And let's go to where I create this hole in the base. So we're going to have to see, I probably do that in the first sketch, right? So I made that hole 7 millimeters. And then later when I made the trunnion, I referenced this hole. Instead of typing in 7 for dimension for the trunnion, I have that trunnion referencing a pre-existing thing. So if I make this hole 9, and now I'll make it even larger so it's more apparent. We'll make it 10. And if I do finish sketch, it should now update, it will update the hole that was in the barrel, and it will update the trunnion pin. So if I go back to this trunnion, and if I isolate it again, you can now see the trunnion is, it has increased the size to 10 millimeters to follow the previous change I did. So if you design something so that it's kind of all linked and referencing previous geometry as you step along, when you make changes, it will update everything on the fly. And that's some of the, the true beauty of a system like this. I'm going to go back to my base and put that change back to where it was. So right now it's kind of grayed out, right? Because I still have the trunnion in isolated, so I have to unisolate everything else. I'm in the base. I'm going to go back to that first sketch, make this back to 7, and then we'll go back to the way it was. So what I want to do now is kind of take you through the steps that I made to create everything. Before I do, was there any questions? Did anyone have any anything that they missed or think that I should cover before I start going through the process of how I made this exact model?
Yeah, do you use just the cube to rotate around? Because I find myself hitting left shift all the time and clicking and contemplating mapping a mouse button to shift.
Yeah, I've gotten used to using the cube. Sometimes I'll use the shift key, but not usually. I just go over and grab the cube. But one thing about Fusion and probably lots of CAD programs in general is there's lots of different ways to do things. Like for panning, I have actually found if I use the scroll wheel and I zoom out on one side and then zoom in on the other side, I can kind of effectively pan by choosing where I'm zooming in. So there are little different ways to manipulate and move things around. And then when we get to different steps, like if you wanted to make a hole with a radius or some different geometries, there's lots of different ways to do it. Like, the two main ways to create solids are either an extrusion, which is this little blue block up here, which just takes a profile or a 2D sketch and moves it along a height, or a revolution, which takes a sketch and revolves it around an axis. Again, if you wanted to make a cylinder, you could either make a rectangle and revolve it around one edge of the rectangle and create a cylinder, or you could create a circle and extrude it up. So there's usually a lot of different varying choices for making things. And one of the reasons why I chose the Canon is because it would allow me to use multiple different methods for the different parts.
Yeah, my center mouse button, it clicks when I hold it, so I can hold it down and pan.
Gotcha. So yeah, mine is just a wheel that when I usually click it, I usually roll off the wheel. So it's not that good for clicking. But cool. It's I use Illustrator and some of the Adobe things, and for that you hold down the space bar to pan, and every once in a while I'll do that on this program and realize it doesn't work. So you do have to get a little used to what you have to use. But yeah, so let's get into, I'm going to back my timeline all the way up to the very beginning. I'm going to turn on my origin so you can see where the start is. And so I started this by creating a sketch. So I showed you the extrude button here and the revolve button. The button to the left of it is create sketch. And so the create sketch is basically most 3D geometries you're ever going to create are going to start with a sketch of some sort. So when you click that button, that sketch button, it's going to ask you to choose a plane. And for this Canon, I chose this plane right here. If I go forward in my tree, this is, actually the very first thing I did was I created the I'm gonna, yeah, just go back one second here. So when you default to a new page, if you create a sketch, you get your planes, and if you start drawing stuff, right? If I draw a rectangle, and if I finish it, and if I want to extrude this up or extrude it out, right, I can start, making a shape with it. It's making this as a body under this primary object in the tree, which if you're only making something that has a single entity or a single thing, that's perfectly fine. If you're going to make something that's going to have more components or different pieces, the best practice is to, when you get ready to start, making it, you're actually going to, there's a few different ways, but if you right click, you can do new component. So you can create your new component and give it a name. So for my cannon here, actually this very first item is I created a new component. So if you look here, right, so I named it naval cannon. Right now the tree ends at origin. And if I do that next step, I now have a new item, a new component. The component is designated by this little square here that is called base. All right, so I created a component first, and then I selected that component so that I'm actually making my sketch, which is this next part here, creating the sketch, is in base. So if I click on this, it goes to, right, the little dot has gone down to base, and so then here's the sketch I created for the cannon base. So I decided to make this by drawing the profile of one side of it and then extruding it out. So I drew the profile. For my own sanity, I chose to start it.
Are the sketches always two-dimensional?
Sketches are always two-dimensional. Now I can still rotate it, right? I can still rotate it around and look at it from the back or the front or at an angle, but it is just a two-dimensional entity. And so like here, like now that I've started rotating it, if I want to get back, I can click the front in the view cube and it'll go right back to that full, true, head-on 2D view. And so I'll typically always start my sketches at like the origin point here. So I started drawing, some lines. I think I actually started drawing this as a rectangle, and then I drew 2 lines here and trimmed the rest of the rectangle. And my thought was, for kind of a future class, whenever we want to do the next one, I would go into more detail on creating sketches and dimensioning sketches and some of kind of the best practices for creating things, because we have other items that are called constraints. Like if you look at some of these symbols, there's like a perpendicular symbol and this little saw symbol and the circle here. Those all mean things, and knowing what they mean will help you when you're creating sketches. But I think this is a little bit more in depth than I want to go through tonight. I want to just more show the steps of how I created the sketches and the planes, and more kind of the thought process on building the cannon, because now that everyone has the model, you can step through it and start playing with it yourself, and you'll have a better idea of what you're manipulating if you want to go change something. So I drew my sketch, and then I drew some dimensions, and you'll see here that the lines of the sketch are all in black. If I delete a dimension, you'll see that some stuff has turned blue. So a blue sketch entity means that it is not fully dimensioned. In other words, the computer doesn't know exactly where it is. It's wherever you drew it, it will keep it there. It will give it kind of like a temporary dimensional assignment, so you can continue working, and change stuff. But you could move it around or whatever for that entity. So I just did Control Z there to undo, when I moved it up, right? So like I can just select stuff and drag stuff, and then I'll do Control Z and move it back. But this blue line indicates that this element is not fully constrained. The computer does not 100% know where this is defined in space. And if you look at this hole, so this hole is 9 millimeters from this top surface. So since this top surface isn't defined height-wise, it doesn't know where the hole is height-wise, because it's referenced off that top surface. And if I wanted to put that dimension back, there's a dimension tool here, the little arrow between 2 lines. I can click on 2 items and then, click and put my dimension there. Now, if I wanted to type in another thing, if I drew it, if I did a rough sketch and it was just a random number and I wanted it to be exactly 40, I could type that in. If I wanted it to be exactly 42, you know, I could type that in and it will make it that number and it will adjust the sketch accordingly. If I want to go back and make that back to 40, I can double click on it, make it 40, and it'll go back to the way it was. The other thing to point out before we leave the sketch is you'll see that my closed profile is shaded blue. And so that means it's a closed entity. If I was to draw something, I'll start here. If I'm just drawing, you know, something with a line and, you know, and I stop it, you know, here, it's not shaded blue because it's not closed in. If you're going to create a 3D solid, you do need to have a closed-in shape. It will not let you create a 3D solid without having a closed-in shape, because again, it doesn't know where that's, you know, where the edge of that is defined. If I then, you know, clicked and closed the points, now it's shaded blue. Now the computer recognizes it as an enclosed shape, and it's a good starting point for a solid. Undo those steps. And then once you have finished your sketch, you do finish sketch and you go back to this view. Now, right now, that sketch is hidden. If I unhide that sketch, you'll see that sketch. And again, I can now, you know, pivot this and rotate this. And so that sketch is now there. And you'll see there's really actually two viable profiles, right? The inner circle is a profile and the whole block here is a profile. And so, and they're both shaded blue because both of them are viable objects that could be created or turned into a 3D model. There are times you would have a sketch that does not have a closed model like that. Let's say you're doing a set of headers or something, and you want to take a circle and you're going to, instead of extruding it in a straight line, you're going to extrude it along a certain path, a sweep or something like that. That's an option here. If you look at, a sweep is something where you have two sketches. One sketch is a line of some sort, a curved line, a straight line, an angled line, and then another sketch is a closed profile. And so you would drag that profile along that line. So that's an example where one of your sketches would not be an enclosed profile. But for here, if I go through the steps here, we're going to use the extrude function. So the extrude function, I can right-click on edit, and you can see the options here, right? So like the profile I selected one profile, which was this surface, which was minus that hole, right? So that it would leave space where that hole was. And then I, was choosing to extrude it in one direction, and I gave it a distance, and I made that distance 38. Well, because I made it in this direction, it's negative 38. If I made it positive 38, it would be on the other side. And then you have some options down here for the operation of like what you want this to be. And in this case, it's a new body. It's the first sketch and the first profile of this body. So it's a new body. But this is where we use these are kind of Boolean algorithms for either joining material as we add more material to an object, or we cut material away, or you can even choose the intersection, right? So you can have, like kind of a Venn diagram. You make two solid bodies, and where they overlap is going to be the material that you want to leave, that your resulting object. But for this one being the first one, it's a new body. So click OK, and then there it is. So that's the start of the base of the cannon. And then the next thing I did, I said, all right, well, let's, the next step I want to do is make that cutout, that kind of notch that went through the center of it. And so what I did to make that notch is I created a construction plane. So using up here, there's a construction feature, and you can create planes and axes and points. But what I started off by doing was saying, okay, I know I want to remove material. I want to have a wall on one side and a wall on the other side. So using calipers, I figured, okay, I want the wall to be a certain distance over. I'd have to look exactly to see what it was here. If I look at the edit feature, so it's 8 millimeters. So I made a parallel plane, so a plane parallel to this first surface where I made my sketch, and I made this plane 8 millimeters backwards. And so once that plane is created, I can now use this plane as a place where I want to draw a sketch. So the next thing I did is I went through and I started another sketch. And so for this sketch, I made this sketch on this plane. So if you look at it, if you look at where my sketch is actually, a little bit inside the model. When you're doing that, when you're working inside a model, there's a few different things you can do here on the side. Like you can slice it and it'll show you like a cross-section view. Like if you have something kind of complex, you might be able to see, where there is solid material versus where there isn't solid material. But what I did is I took the edges of the existing object. So I pulled those edges as a reference called a projection, right? If you think about wherever your plane is, you take an edge of your shape, and it projects or it goes out to where your sketch plane is, and then it draws that line on your sketch, right? So if you had a circle at an angle and you projected it, it would be an oval on the plane. So, but this being rectangle and square, my projection of the surface is just the surface. And again, these lines, if I moved one of the lines on that base model, these projected lines would move with it. What it allowed me to do is draw my diagonal line, and it allowed me to only need two constraints: a distance from one edge where the diagonal line started from the surface, 11 millimeters from this bottom surface, and then I gave it an angle of 10 degrees. So, and then now this is really defined, two different shapes, right? There's the bottom half and the top half. So as I finish this, and so when I drew this, when you select like a construction plane and then you create a sketch from it, it will usually then hide the plane once you're actually working with your item, so that just to make it a little bit cleaner. So then when I finished the sketch, I then went to extrude, so I can step through one more time, and we can look at this feature, right? So I selected the top part of that sketch that I just created, and had it extrude it this direction 22 millimeters. And if you see, it's highlighted in red, and it's because the operation here, our Boolean operation, is a cut. So it's going to remove material, that is in its way, or where its path is. And so by removing that, clicking OK, we now have our notch through the center. Any questions so far on the logic for creating that? Okay. And so I'll go a little bit faster. So then the next step I did is I created the holes for the screws. So again, I just went back and created another sketch, and I created two circles, dimensioned them where I wanted them, and then did another extrusion, and then this extrusion again was another cut, and so it created two holes. And for this, I made them only go partway through, only because that way it would give me the option to then do it again. So I made another sketch that was on the other side, and another extrusion, so kind of I followed the same routine, but I did it on the other side. And if we go to that sketch, you'll see there's no dimensions on this sketch, because what I did is I made these holes projections from the circles on the other side. So again, if I change one of the diameters of one of those, it would automatically update and change the ones on this side too. And then I played around a little bit with, there's a thread feature in your in Create. You can actually create a thread, and creating a thread looks cool. And I'll step through and, do it here. You can see that it actually does, draw a little thread in your hole. It doesn't actually change the geometry of the hole. It is still, from like a solid modeling perspective, just a hole, but it has added kind of a graphical feature to help you remember or understand that it's a thread. And if you really wanted to cut material away, it is possible. It takes a fair amount of computing power, and then as you start to update your model, it would kind of slow down model in the future. But by using this thread feature, you've identified it as a thread, and it displays as a thread, but it hasn't actually changed the complexity of the model.
And so for those holes, I mean, if we think about it, actually machining the part, they would probably be undersized with respect to the M4 bolts that you're threading into them. Does the program care about collision between the dimensions of the larger bolt with the smaller hole?
So you can do that. There is a way that you can inspect and look for collisions between parts. That is a feature that you can do that we can get into at another time. I made this so right now I did specify these threads as just an M4. And if you go back to the sketch where I created it, I did just make them 4 millimeters. But you're right. If you wanted to make this as a 3D printed or a machined model, you would choose your tap size, which is 3.5 or so, or 3 point something, and you would actually do that. Yep.
Okay, yeah. So the program will tolerate collisions unless you turn on that feature.
It will tolerate collisions, and if you turn on that feature is only used to identify them. Like it doesn't, the program's not going to necessarily know, because you might want to, press fit or something like that. So this is something more aware. Depending on how you're going to manufacture this, you'll have to make the decision. Is this going to be the right nominal size hole, a tap hole, or something like that? Was there another question?
Yeah, Van, it's Preston.
Yeah.
Just so if you exported this with that feature for 3D printing, it'll just end up with a smooth hole, right? Not like an M4 threaded thing.
That is correct. Yep.
And so I messed around with this a little bit last year working on some fuel tank adapter stuff. And I know, well, I remember a little bit about the troubles I was running into with that. If you actually want to make threads, like real 3D printed threads or metal printed threads or sintered, whatever, what is the main stuff holding us back there?
Yeah, so the main step would be we would use probably like the sweep feature. We would have to create a like a coil shape, or would have to create a path that is circular but goes around like a helix. Yep. You'd create that path around it, and then you'd have to create a profile that would either probably be kind of like a triangle or a rounded triangle or something along those lines. So then it would take that shape and as it revolved it around, remove that material. So you would
so basically you have to define the whole thread yourself.
That's right. Now there are probably plugins that you can get for Fusion that you can put in parameters and would help you with that. I was actually helping my son with it. He was designing some gear they wanted to 3D print, and we found a gear plugin that allowed you to put in like your number of teeth and your pitch and your root diameter, and then it would create that model for you. I would imagine for kind of plastic threads that you would 3D print. Now 3D printing, the resolution, you're going to need a pretty coarse, pretty large thread for that to grab onto. So, but I would imagine there's some plugin that would let you do that.
Could you take a Mcmaster bolt or screw and then use that to take out material? I don't know how good their models are.
Yeah, so so the screw model that I have in here, I did pull from Mcmaster, and I was going to show that in a little bit when I got there, how you can actually, there's the insert tab here. You can choose a Mcmaster component. It will open up a Mcmaster window. You can, oops, I had to double click on it.
That is awesome.
You can choose your item. And let me just try to get it without that blue there. Let's try that again. Insert Mcmaster component, do a screw, we'll choose a larger size. I don't know. Well, let's choose we'll do M8 maybe. We do more with metric stuff.
I noticed the Allen cap screws you use there are safety screws.
Yeah, it was something. So yeah, so you can find a part here. We can choose a length, and if I scroll over to the side, and if I click an item, there's the CAD one, and you can choose the 3D SolidWorks CAD. And if you download it, it will. Oh, I guess I have to choose step. 3D step. And download. It should give it a minute and should pull it in. So there's that screw, and so now it's letting me place it. I can rotate it with these little global things here. I can zoom in, or I can move it through space. And if I do OK, it is now an object in my tree structure, and this does have the threads on it. So to the question, so let me see if I can move this enough. We'll just do this real fast here. So let's see. If I right click on an object, I get a menu of options, and move is one of them. So let's see if I can move this. I can either move it on a plane. Go to that front view. I probably shouldn't have tilted it the way that I tilted it, because now it's like, well, so here it's all right. So here it's kind of intersecting. I'll move it down 35, 40. Let's make it like 38. All right. So it's like intersecting through our object there. And I wonder, can I do a? Can I? This, because usually, to create an extrusion or revolution, we're using a profile where this is a solid. I guess I was looking to see if I found something quickly that looked like it would, I could just delete that from it.
What does the mirror do?
So the mirror function, right? So if I have this screw here, I can choose a mirror and capture that position. If I choose an object or something, and then I choose a mirror plane, it will create, mirror image of it on the hood. It did not like that. It allows you to take a feature. So like, I've got a good example, actually. I'll jump away from this. Let me just undo a few times from adding that screw. But I can pull up, like I was working on the front end of the turkey on the 944, creating an aluminum kind of front frame structure. And you'll let it load up here. So this is a pretty big file. So I made this out of a lot of sheet metal. And I think some of you might have seen it or seen pictures. It came up pretty decent. But this is mostly sheet metal components. But what I did is I did draw like the radiator and the oil cooler and the oil filter as solid objects, just so I could kind of visualize the space. But I had to replace the front frame rails of the turkey. And so when I designed this, I set my origin. I took a lot of measurements, and I set my origin so that this plane would be right in the center of the car. So as I drew components like the frame rails or these straps coming down, I could then mirror one, choose this plane as the mirror surface, and it would create the object on the other side, the right distance away. So that's the
Thanks for that explanation.
Yeah. While I have this open, one thing I was going to share and show is that one of the neat features of the sheet metal, working with sheet metal in Fusion, is that if I go to like this frame on the side here, if I select this item, in fact, I'll isolate it so we only see that item, right? So here's my, kind of a sheet metal rail here. So to create this, I had this laser cut out of metal, out of aluminum, and so I've created it in Fusion in this sheet metal feature. I have the option to create a flat pattern, or like what does it look like if it's unfolded. And so here is that part unfolded. So it will, figure out the, I use the stock parameters, but you can put in parameters for like your bend radii and things like that. And, it'll make sure that like, material doesn't interfere with other material as you unfold it. And I was able to then take this pattern, make a DXF, which is like a 2D vector file, and send that to an online laser cutter place. And a few days later, had this in my hands ready to fold up. And there it is, folded up. So again, that's something I'm hoping to, in another day, go through kind of the steps of, working with sheet metal, how to use the sheet metal functionality. If you're going to do like tab and slot construction, like if you look on, kind of the underside here, like I have some kind of, locating tabs and slots to help line it up. So then I could tack load it together once I had it put together. Another spot that has the tabs and slot, kind of creating those, what tolerances to use to get them to fit together is something I'd like to cover at some point. So let's
that really makes the Canon look boring.
It does. Well, let me just show you one more thing on the Canon, because I want to talk a little bit about the revolutions, right? So we've done the straight extrusions, but now let me get to where the barrel is. Where's the barrel? Here we go. So I've made the component for the barrel, and then I'm going to create my sketch. Well, to back up just a little bit here, let me turn on these construction items. So actually what I did is, I got to finish the sketch. I created a plane that was right in the middle of the object, and then I created an axis that was intersected with this axis. So I created a plane in the middle. I created a plane right here. This plane is parallel to this ramp inside the base, and it goes through the exact center of the circle. So I made this axis in the circle, created an angled plane through that was parallel to the base, created a plane in the middle of the base, and then I created this axis, which is really the intersection of these two planes. This plane and this plane, where they cross, is this axis. So that axis I know is lined up with my hole in the center, my hole in the base, the trunnion hole, and it's at the right angle for the ramp. And so by doing that, this allows me to, when I create my sketch, create it in right in that spot there, right? So I'm kind of looking down on that plane, and I'm able to then, in fact, I should probably isolate this barrel so you can see it better. I'm in pan mode. So this sketch, I've drawn a shape that I'm going to revolve, and I've made one side of it coincide with that axis that I drew, that axis of those two planes intersecting. And so, if I kind of zoom in, it's pretty straightforward. It's got some little radii, it's got some angles. At the breech end, it's got some little steps. And there's my sketch. And so this one is going to be a revolution. So when I go to revolve the item, let me unisolate. When I go to revolve this, kind of the same thing as when you do an extrusion. You select your profile. I selected this profile of the sketch. You select the axis about which it's going to revolve. And I chose, again, that axis between the two planes. And then you can actually choose an angle. So for this, I wanted it to go 360 degrees around, but you could do any number that you wanted. If you only wanted it to be half, or, if you were making some shapes that didn't require it to go all the way around, you could do that. And then, of course, it's a new body because it's a new component. It's the first one of this component. And so then when I create it, there it is. There's that barrel. So those are the two kind of major features of creating solids in any 3D program, whether you're using Tinkercad or SolidWorks or Fusion. Revolving and extruding are the main ways to make stuff. And then from there, I think I made the hole in the side with the trunnion pin, where it's going to pivot around. And then I made a sketch that was just a circle and made a hole for the barrel going in. And so right now that hole goes in, and there's a flat bottom. And then actually what I did was made a little chamfer. So it's actually like the way a drill bit would be. It would have a taper at the bottom. And let's see, what did I start doing next here? I think I started making that trunnion pin. I created a new component, and I pulled that circle, and then I just extruded it. So the trunnion is based on the circle that's pre-existing. And then, the distance is also, I just use the pre-existing faces. So if I make the base wider, the trunnion will get wider with it. Again, if you were going to make this, if you're going to machine this or 3D print this, you might decide to make the trunnion a little oversized, or make sure that the hole, I think I made the hole in the barrel. I think that's this one, right? So for this hole in the barrel, I made it, you remember that trunnion was 7 millimeters, this is 7 1/4. So I made it so that, it would pivot on that.
You can't, can you put formulas in? Like reference something plus 10%?
Yeah, you can. I've never tried percents, but I've done, like a current existing dimension plus something. Yeah.
Clearance. Got it.
You absolutely can. Yeah.
That's cool. Oh, so with the screw thing, if you use the combine under modify, that's how you get that Boolean.
Oh, okay.
So you can combine and say cut, and then you just pick your target and your.
Combine. Yeah. Look at that. Good.
So then you make the screw the tool and the target the body, and it appears to work.
Cool, and it would remove that material. Excellent. And then stepping through, I create the wheels. The wheels are straightforward. So these wheels I created just as a circle and extrusion as opposed to a revolution, to show that there's a different way to do it. And then this little item here is where I pulled in the screw, the Mcmaster screw. And then once I've pulled the screw in, I created an axis for going through that hole. And then I used some features. I made another wheel first, but then I used the features under modify for align. And align lets you move components around. Like, you can right click on something, and use the move feature. And again, you can kind of drag it or type in, numbers for where you want to move something. But you don't have any constraints, where when you use the align feature, you can, give me more options there. You can choose like faces, touching faces, or coinciding axes or things like that. So as I, move the wheels around, I aligned them with the axes of the holes and made them touch the face of the base. And then as I created unfinished position. As I brought in the rest of the wheels and the screws, I made them so that they would touch, the line up with the axis and touch the face of the wheel, so that they were in position there. And so then there you have it. That's the steps that I used to create that cannon. So hopefully that gives you enough ideas and knowledge to start, taking that model and stepping through it and looking at the different steps and the different procedures. And I can, click on anything either in this timeline, right? So I can look at, this is the revolution for the barrel, and here's the sketch. Or if you activate a component, if I go and activate the barrel component here, I will see a shortened timeline that is the steps that just applies to that component. So that can make it easier to work with it. And then again, if I, activate the, just shrink down some of these things. If I go and activate the parent or, the top level model, I see it all there.